cloud. Okay, so we're gonna do this bad boy. It's a bad girl, you know. I don't know. This puppy. I used to like to call things puppies. So here we go. Given. Let's see. We've got this is the y-axis. Here's the x-axis. Okay, so this is number 3 on the practice. Okay, and then there's some kind of shape here, and this distance right here is r. This distance right here is r. And then we've got see if I can draw a good arc. Kind of looks like that. And really, I draw this like this. This is a square, or so that's a square with sides r, and then here's a radius r. Okay, so we want to know the centroid of the plane area. Okay, so let's see here. It says a given required. We want the centroid. Okay, solution. So the first thing to note is if they want the centroid, they want x bar comma y bar equals what? Okay, it didn't say it in those words. It just said let's find the centroid. Okay. So in this case, r is for me, r is 85 millimeters. Okay, let's go ahead and give this a guess. What do you think for the centroid?
Is that one of those spandrels?
Spandrels. What is a spandrel?
That's what it said on the chart, I think.
That's what said on the chart. Spandrel? I'm not sure what a spandrel.
I don't know. On the chart, there was a parabolic spandrel and a general spandrel.
Hold on, let me see. What page was that chart on? 290 something, I think. Nope, not there. Do you remember what page the chart's on? Probably not, because you don't have a physical book, right?
I'm not sure.
Let's see. It's chapter 5. Here we go. Yes. Oh, a parabolic spandrel. All right. So how would we know if something is a parabola or parabolic?
If it's squared.
Right. Well, yeah. So if it's so parabolic means y equals x squared, right? Y equals x squared plus, it could have another, well, I guess it would have this form. Ax squared plus bx plus c, right? It could also be x equals different a. So we'll do a capital A y squared plus by plus a capital B plus c, right? So either one of those would tell us it's a parabola. Do you see a parabola here? What do you think this shape is, right? What do you think this shape is? It has a constant radius. Okay, what is this shape right here?
Like the surrounding part of it?
Yeah.
Like a square?
All right, cool. We got a square. Okay, what is this one right here? If I were to keep going. And assuming I could draw better.
A circle.
All right, good. Okay, so we've got a square and we've got, well, in this case, it's actually a quarter circle. Okay, it's not a parabola, it's a quarter circle. Okay.
Okay.
All right, so let's, all right, so here we go. We got some shapes. Okay, now let's get back to the question at hand. Where do you think the centroid is? I know I'm putting you on the spot, but you're the only one here, so I have to put you on the spot.
Somewhere in the middle.
Right here?
Would it be somewhere in the middle of the I don't know what it's called, like the lower left part?
You like that?
Yeah, somewhere around.
Okay, so if R is 85 millimeters, give me a guess for X bar and Y bar. Just a guess. Don't stress out about it too much. What do you think the coordinates are in X?
$20.
Okay. What about in Y?
No, 30.
You think it's higher? Okay. 30?
Yeah.
So it's good. It's good always to kind of just give yourself a guess so that we can kind of, okay, this is a guess. So I'm just going to put a little green question mark about over the top. All right. So how do we get it? How do we get a centroid? Do you remember the formula?
Equations on the chart.
What's the equation?
It's the quarter circular area.
Okay, yeah, we can do that. But what's the equation for X bar and Y bar?
Oh, it's the sum of X bar times A over the sum of just the area, right?
Yep, you got it. And this is the same basically, except with Y's, right? Okay, so let's go ahead and solve this. So I got this shape. So we need these things in our chart. All right, so I need X bar, A, well, X bar, Y, and then Y bar, and then A, right? Y bar, A, X bar, A, Y bar, A. Okay, so that'll give us everything that we're kind of looking for. Okay, so let's see here. All right, so which shape do you want to do first?
I guess I could do the square since it's first on the list.
Okay, so where's the centroid and the X for the square? By the way, it's not in the chart. The chart, interestingly, does not have it. So you just have to know it. Where is it?
Is it a half base times height? Wait.
No, we just want to know where the center in the, what is the X coordinate of the center of the rectangle?
Oh, is it half of the radius?
Yeah, well, in this case, yeah, it would be an R, but it's half of a side, right? So it's half of 85, so it's going to be 42.5. Okay, what do you think Y bar is?
Also half of the radius?
Yep, 42.5. Okay, what's the area?
Is that a half times the both radiuses?
A half times both radiuses? What's the area of a square?
Is a half base times height, right?
Where is this half? You've said a half every single time. What is a half coming from?
Like half of the square?
You only want to do half of the square?
I thought that was what it was to get the center.
Oh, right. If we want the center, but right now I just want the area.
Oh. So it would just be base times height.
Base times height. Okay, so what is that? Tell me what to put into my calculator.
is it 85 times 85?
Yep. 7225 millimeters squared. Okay. So now what do I do for X bar A?
You multiply X bar times A.
Okay. So what, tell me, put in the calculator.
42.5 times 7225.
Yep. I mean, unless you want to do it. I mean, all right. So it's 307,307,062.5. Probably a few too many sig figs, but whatever. And then it's going to be the same for this one, 307,062.5. Okay. All right. Now let's do our quarter circle. Okay. What is
Okay.
X bar for a quarter circle? So you have that chart out in front of you?
Yes.
Okay.
4r over 3 pi.
Okay, so 4r over 3 pi. So that's coming from the chart for a quarter circle. Okay, and so tell me what to put in my calculator.
4 times 85 divided by 3 pi.
Yep. Okay, so 37.075. Okay, and that has units of millimeters. Okay, so what is that for over here? Right, because need an X bar. So where is this 37.075 measured from?
Is it from the left?
So it's measured from over here?
Yeah.
Look at the drawing. Okay, because I sent you guessing, but which is okay. But let's look at the drawing for the quarter circle area. X bar is measured from the curved side of the circle or the flat side of the circle?
Oh, from the curve.
Are you looking at the
Right.
same drawing I'm looking at? No, look at
Wait.
No, you're looking at the screen. I want you to look at the chart.
Oh, okay. Okay, so it come from the right.
Okay, you see how it's going from the flat side?
Yeah.
So okay, here's it. I mean, it's reversed actually, right? They have it drawn opposite the way I have it, but they have X bars going that way, right? So in this case, yeah, they have a little thing like this, right, or something. Anyway, so it's actually coming from this side over here. So what number am I going to put right down here?
$37.075. Wait, no. Would you subtract it from 85?
Yep, because here's our origin, right? Yeah, so it would be, so we go this way, 85, and we come back this way, 37.075 to get to the centroid of that thing, and the X coordinate of it. So it's somewhere along this line. Okay, so let's see. So we'll do 85 minus 37.075, and we get 47.925. 47.925 millimeters. Okay, what do you think is going to happen in the Y direction?
Something similar. It'll go
Okay.
down. You'll have to add, you'll have to subtract 85 from whatever the answer is.
Yep. So what do you think the answer is, though? What do you think so we got to get the Y. So it's going to come from, let's see, I'll do this in green. So it's going to come from this side, right? So what's the equation for the Y bar?
Also 4r over 3 pi.
Yep. So it's the same number. Okay. So this number is going to be 47.925 millimeters. Okay. Now we need the area. What's the area of a quarter circle? I'm going to go ahead and erase this.
Pi r squared over 4.
Yep. Okay. So I'll go ahead and do that. So what's that? Pi times 85 squared divided by 4. So we'll get 5674.5. That's millimeters squared. Okay, so what do I put in my calculator moving forward?
Multiply 47.925 and 55,674.5.
Yep, 5674.5. Okay, so this is we're kind of having a struggle in some space here. 200. Let's do this. Okay, 271,950. Okay, meters cubed, and this is going to be the same. 271,950 meters cubed. Okay, so what do we do?
We sum the x times a and y times a over the area.
Okay, kind of, almost. What did we forget to do?
Oh, add.
Huh?
I said add them.
Yeah, almost. So this is summation, but notice that this area, so the area of the square is all, it looks like this, right? Am I adding this semicircle on top of that? And am I going, okay, let's now add a semicircle on top of that? Okay, the answer is no. What am I doing?
Subtracting.
Yep. Okay, so this area needs to have a negative sign in front of it. Okay, and so then when we multiply these things, we're going to get negative signs here and here. Okay.
Okay.
So then when I add them, now I'm adding this number to a negative number. So I'm going to get, a number that's going to be a little bit smaller, or a lot smaller, really. So 72.25 minus 5674.5, and we get 1550.5, 1550.5. And I'm only going to do X bar A or Y bar A. It should be clear at this point that they're the same. Okay, so X bar A becomes 307.062.5, too many sig figs, minus 271,950 equals 35,112.5 meters cubed. So then to get our final answer, we're just going to take this sum and divide it by that sum. So I can say X, come on, man. X bar equals that divided by 1550.5 equals, that's interesting. I wonder if we made an error somewhere. 22.65. Well, 646. And notice that's also equals Y bar because they're the same. Right, and that's meters, millimeters. Sorry, I wrote meters. This is millimeters. This is all millimeters. I don't know where I lost track of my units. Okay, so then I would say that X bar, Y bar equals 22.6 millimeters, comma 22.6 millimeters, like that. Okay, that's the answer. Questions?
No.
Okay, so I'm very curious about this. We did get in a different answer than the book, which is interesting because we have all the same numbers. Oh no, X bar 48.92. Maybe I plugged something in a calculator wrong. Check something real quick. 4 pi over 4r over 3 pi. Let's try that again. 4 times 85 divided by 3 divided by pi equals, whoa, that's interesting. So there's a mathematical error in here somewhere. 48.92, and I got a way different number than that. Well, suffice it to say, there's a math error in here somewhere. I think it's right here. Okay, because when I plug that in again, 4 times 85 divided by 3 divided by pi, I get 36.075. So this is an error, 36.075. Okay, but the procedure is correct. Okay, so this is what we would just do this. Okay, so let's not worry about the answer here. However, your answer here, this guess was really, really, really good. Okay, what you missed was the fact that it should have been X and Y should have been the same. And
Okay.
so the way that you can tell that really by symmetry is, but the symmetry goes in this direction, goes on a diagonal. Okay, so if on that diagonal it's symmetric, then it's going to be the same. Okay, so you may or may not be able to see that, but as soon as you start seeing these numbers, like if you look for X bar and Y bar for all of these shapes, and it gives you the same formula for each one, you know, like for a rectangle, it's just length divided by 2, length divided by 2 for the rectangle, right? And then for the quarter circle, it was 4r over 3 pi in both directions, 4r over 3 pi. So once you start seeing that all of these are the same, you go, okay, what's going to be the same? Okay.
Okay.
So let's do another one of these. Let's go, let's see here. Oh yeah, I need to find a new problem. Let's clear all drawings. Okay, let's see what the next one is. Okay, so ooh, this one's hard. This one's quite hard, in fact. You know, maybe this will be our parabolic spandrel. Okay, this will be number 4. Okay, so this is taking it up a notch. Okay, so we got Y and X. Okay, I want to just make note that this is 0, 0. That's the origin, so we're going to measure everything from there. Okay, let's see. So now we've got, let's see, 20 millimeters. I don't know. They love to do millimeters on these sorts of problems. Okay, this thing's going to go like this. Okay, so that's going to be X equals KX squared. Yes, this is 20 millimeters on this side too. Okay, then there's going to be a circle right here. So this is going to go like this. And I can draw a circle, which is, I can't draw a circle. At least not at this angle. I can do it. All right, let me turn my eye thing. I think I can draw it from this side. Okay, that's not, well, that's terrible. All right, give me one more try. Sorry, it's there you go. That's way better. Okay, so now we've got R. And R in this problem equals A. So this is A right here. And this is R. And they'll say, okay, well, R equals A equals 30.4.5 millimeters. Okay, I'm going to change that. Let's make it 30 millimeters. I don't want to deal with 34.5. All right. So give me your best guess of X bar, Y bar. Required, we want X bar, Y bar. Okay, the location of the centroid. What's your guess?
The whole area or distance is 30 millimeters for it.
Yeah, so this little A at the bottom, this is 30 millimeters. Okay, and I guess this one is 30 millimeters here.
Would it be like 2040?
Okay, so let's see here. Let's give a guess. So 20 is about right here. And 40 is about right. Maybe. So this is the whole thing is 50. So maybe 40 is about right here. So that's like 20, 40. What do you think? You like it?
Maybe not 40.
Okay. 20, 30?
Maybe.
Okay, let's go with it. Okay, 20 in the X, 30 in the Y. Okay, we're doing this kind of like a science class, right? A hypothesis, and then we're going to test it. Okay. When I used to teach science, I used to make my students take guesses, and I've never had a student who was comfortable with it because we don't ask people to do that often enough. I think if a teacher had asked me, I'd been like, "What? How am I supposed to know? Like, I just started looking at this. How am I supposed to figure this out?" This is not important if you're right or wrong. It's just important to start kind of gathering some intuition about where it would be. Okay, so let's do the solution. And we already know we're going to do this big fancy, like, okay, so let's remember summation. So X bar equals the summation of X bar A over the summation of A, and Y bar equals the summation of Y bar A over the summation of the A. Okay, so let's do our little, well, it's not really a little chart, is it? It's kind of a big chart, actually. I'm going to create some space for it over here. Or wait, how much space do we need? I don't even remember. Okay, so X bar, Y bar, A, X bar, A, and Y bar, A. Okay, so what shapes do you see? I'm going to erase some noise so that just so that we can see what's going on here.
Is that another quarter circle?
There is a quarter circle, yes. Okay, so let's go, and I'll just put the shape right here. So we've got a quarter circle, and it looks like this. Okay, so talk to me.
And is this our spandrel?
What's that?
Is this the spandrel now?
It does look like a spandrel, doesn't it? We like this word spandrel. The parabolic spandrel. Okay, so I'm going to draw that like this. Okay, do we have any other shapes?
There a rectangle?
There's a rectangle. Okay, well done. Perfect. Okay, so it looks like I'm going to have some space issues, but that's okay. So talk to me. Let's. What do we do with? Which one of these do you want to do? Well, first of all, let me ask you: are any of these negative spaces, like spaces that are removed, cut out?
The spandrel.
The spandrel, right? So because of that, I'm going to go ahead and give you a negative for the area, and I'm put negatives here and here because we know that we're going to end up with negatives in those spots. Okay. All right. So now all we got to do, well, I mean, it's kind of hard to see. Right. Those are here. Okay. So yeah, I'm definitely going to have trouble with that rectangle. Rectangle is the easiest one, right? Hopefully. All right. So let's do it. So what do you think for that quarter circle?
For our over 3 pi again. So, okay, so 4 times over 3 pi.
Right. So what's the radius in this case? 30, right? So that's 40 over pi, I believe. On 40 divided. Hopefully I won't, mess this one up. 40 divided by pi. So that's 12.732 millimeters. Okay, which side is that measured from?
The left.
Right, because that's the flat side, right? Okay, so am I writing down 12.732 or am I writing down something else?
12.732.
Perfect. Okay, so the X bar is 12.732 millimeters. Okay, what about the Y bar? Actually, let me go ahead and put the units up here, but go ahead. What about the Y bar?
It would be the same as X bar.
Sure, so what am I writing down?
12.732. Wait. Yeah.
Is it 12.732 from 0, 0?
No. 20 plus 12.732.
Right? So what's that? No calculator.
32.732.
Good. Okay. What about the area of a quarter circle?
That's pi r squared over 4.
Right. Okay. So we got pi times what? 30 millimeters. So this is the area. Not that. Squared divided by 4. Okay, I'll use my calculator for that one. Pi times 900 divided by 4 equals 706.86. 706.86. Okay, and now I'll just go ahead and multiply because you know how to do. You can see what we're doing here, right?
Yeah.
Okay. Yeah. I know. I'm just making sure. When I've got we have one more student, but she's not speaking up, so so we'll just keep on rolling with it. Times 12.732, and we get 8999.7. 8999.7. That's cool. And then we'll do 706.86 times 32.732 equals 23,137. 137. Okay. Let's do that spandrel.
It's 3a over 4.
Well, this is
the
really
X
weird.
bar.
Yeah, it's really weird because they actually have. The problem is if you look at the chart, right? It's got a y equals k to the x, right? But they're giving the positive space, and we kind of need the negative space.
Oh.
How do we do this? I hadn't given this very much thought at all. Oh no, wait, you're right. You got it exactly right. Let's keep rolling. You've got it exactly right. Sorry, I'm crazy. You're doing it right. Okay, so hold on. I'm going to close this door. Somebody's doing some noisy guard work. All right. So talk to me. So what am I calculating for X bar?
So it'd be 3 times 30 divided by 4.
3a divided by 4, where a is, yeah, okay, so 3 times, it looks like 30 millimeters divided by 4. So that's 90 divided by 4. What's that, like 22 and a half? Something like that? Yeah, 22 and a half. Okay. So, yeah. 22.5. Do I want 22.5 or do I want some other number?
Is it from the right side for this one?
Well, look at the drawing. What do you see? Oh, by the way, this should be like this. This should be a Y.
So it's coming from the right side for this one since it's upside down.
Well, where is the drawing coming from, the point or the flat side?
From the flat side.
Okay. Do you see where the X bar is on the drawing?
Yeah.
So you see how it's drawn like this? And it says like, so here's the centroid right here. And then it's got a drawing like this, and it says that's X bar.
Yeah.
So you see how it's measuring from the point right here?
Yeah.
Okay, so we want to measure from this point here this way.
Okay.
Okay, so the answer here is well, it should be if we had done this right, but we haven't. This is my fault. I wasn't paying attention. So okay, so you see how for the parabolic spandrel, okay, do you see how it's got a formula that looks like this? The formula says, for this thing, it says y equals kx squared.
Yes.
But we have a formula that looks like, so that's for a very specific thing. We've got this, x equals ky squared. So I'm gonna do is I'm gonna rearrange this. So I'm gonna say, well, we're gonna say, instead of, we're gonna say this, so x equals ky squared. So y squared equals x over k. So y equals 1 on k to the 1/2 times x to the 1/2. Okay, does this look like that? The problem is the power. Okay, I'm not so worried about this because this number right here is a constant no matter what. Okay, so that's not the problem. The problem is this is being raised to the 1/2 power. So do you see underneath the parabolic spandrel, there's a general spandrel?
Yeah.
Okay, and so for that one, we can get an X bar for any kind of shape. I mean, for any power. Okay, so the formula there for the general spandrel is n plus 1 over n plus 2 times a. Okay, so what is n in this case?
So the power of the exponent.
Right? So what is that? Looking over here.
1/2.
So this is going to be equal to 1/2 plus 1 over 1/2 plus 2. And then what was a in this case?
30 millimeters.
Right. Okay, so it's just a little bit more tricky. Okay, so then we'll do that times 30 millimeters. Okay, so 1/2 divided by 2.5. Okay, so what's that? 0.6, I believe. Clear. 1.5 divided by 2.5, 0.6 times 30, so it's going to be 18. Yeah, 18 millimeters. So 18 millimeters. Where's that measured from?
The left side.
Yep, 18 millimeters. Okay, what's y bar for this thing?
N plus 1 over 4n plus 2 times h.
Yeah, okay, right. So kind of annoying. So n plus 1, that's 1/2 plus 1. On the bottom, we've got 4 times 1/2, so that's 2 plus 2. And then h is what in this case?
Is it the 20 millimeters?
Yep, 20 millimeters. Okay, so we've got 1.5 divided by 4. So that's what, 15 divided by, clear. 15 divided by 40. Okay, 0.375 times 20 equals 7.5. So it says 7.5. Where's that measured from?
Is it from the flat side?
Yep. So am I writing 7.5 down, or am I writing something else?
It would be 20 minus 7.5.
20. So we're going up to here, and then we're coming back down. 7.5.
Yes.
That sounded like a question mark.
Wait, what?
That sounded like a question. Okay, so here's my here's my origin. I want to know the distance in this direction from the origin. So if I look at this picture in the book, right, the general spandrel looks like this. Okay, it's measured, it says Y bar, so it's got a little C here. It says Y bar, like right over here, it's got a little line like this. And then it's got a little line like this. And it says this right here is Y bar. Okay, so if I said that Y bar is 7.5 millimeters, is that the number I want? Is that measured? Is that the same thing as this little red line that I have over here?
Oh, so that would be the same thing?
Yep. Okay, so we got 7.5 right here.
I thought it subtract because the spandrel was upside down.
Oh, right. So the thing is, because our power is less than 1, ours actually looks like this, right? It's actually it's got more of a shape like this. Okay, but Y bar is still here and it's still being measured like this. Okay, X bar is still being measured this way.
Okay.
Okay, it's just because our power is less than 1 that things get a little bit weird. Okay, so now we need the area of the spandrel.
That is AH over N plus 1.
Right, so A is 30 millimeters. Okay, H is 20 millimeters. Divided by N plus 1, so that's 1/2 plus 1. Okay, so that's what, 600 divided by 1.5. So it's going to be 400, I believe. Let's go ahead and check. 30. So this is my form of my own personal hypothesis testing. I'm pretty sure what the number is, but then I use a calculator, so we get 400. So notice this is a negative 400. Okay, now I'll go ahead and do the multiplication here because I think this is fine. So this will be 7,200, negative 7,200. And this one will be clear, 7.5 times 400, and we'll get 3,000. Okay, now let's get back to something hopefully a little more straightforward. Let's do the rectangle. What's the X bar for this rectangle?
This isn't on the chart, is it?
No, the rectangle's not on the chart.
So for X, is it similar to the square?
It's very similar to the square. Yeah. Where's the center?
Is it exactly the same as the square?
It's exactly the same as the square, except that the X and the one side's different than the other, but the formula is the same.
Should be 1/2 times 30.
Right? What's 1/2 of 30?
15.
Right? Okay, what about the Y bar?
1/2 of 20.
Which is?
10.
10, thank you. Okay. And in those cases, you can see that, the center is, it's 15 that way and 10 this way. So we don't have to like add or subtract anything. Okay, what's the area of this particular rectangle?
It would be, is it the same as the square as well?
Same formula, yeah.
So it would be 20 times 30, 60.
600, yeah. Okay. And then what about the X bar A we're just gonna have to do. So the X bar A is 15 times 600, so that's gonna be 9,000. And then this is gonna be 6,000. Okay, such nice, pretty numbers. Was this 3,000 or 3,600? Stupid handwriting. This is how like a lot of my students lose points this way. I used to lose points like this. 400 times 7.5 is 3,000. Okay, it's because your handwriting, you read your own handwriting wrong and then you do it wrong. All right, so then from here, we're just going to go ahead and I'm going to erase all this business. Okay, so this was a bit of a doozy, but I mean, it was a really good one to have to do though, because it brought up a lot of good points that we want to worry about. Okay, so X bar A, so let's see, X bar A. So basically I'm gonna add all of these up. Let's see here. 8999.7 minus 7200 plus 9,000 equals. So X bar equals 10,799.7, 10,799.7. That's millimeters cubed divided by the area, which is going to be 706.86 minus 400 plus 600 equals 906.86. 906.86 millimeter squared. Y bar equals same number on the bottom, 906.86 millimeters squared. And then we're going to add these. Remembering to subtract 23,137 minus 3,000 plus 6,000 equals 26,137. Okay, so let's go ahead and do these. Divided by 906.86. 28.821 millimeters. Okay, looking good. Okay, X bar 10,799.7 divided by 906.86 equals 11.909. 909 millimeters. Okay, so X bar, Y bar equals 11.9 millimeters, 28.8 millimeters. Okay, so this guess not so good. This one really good. Okay, as you know, it's pretty good. Especially, I mean, the Y bar, you nailed it. I don't know what I would have guessed for X bar. I think, I mean, I like to believe I would have done better than you, but I don't know for sure. Right, 20 to me was a perfectly reasonable guess. So yeah, so good job. Shall we do another? Any questions?
Yeah.
Okay, let's do another. Let's see. It is 10:28, so we got 15 more minutes. So let's see what we can find here. Let's see. Let's go to the next one. Do a 3D one. We're never going to have time for a 3D one. Whew, that one's nasty. Okay, let me find one on the internet real quick. Let's see here, Centroid. Let's do one by integration. Let's just see if I can find a one that I haven't done before. Let me get images. Okay, yeah, let's do that. I can't remember which one I did by integration the last time I did this. You know, we could do this particular spandrel right here. Let's do this particular spandrel. X equals y, ky squared. Okay, let's do x equals ky squared. So let's clear all this, clear all drawings. Okay, so we're going to do this by integration. And I want to know, okay, so this is x equals ky squared. Okay, and I think we're going to use the same things we had from the last problem. So what do we have? We had what was the x coordinate? I don't remember. Was it 30?
Yeah, I think so.
Okay. I think it said that this was 20 millimeters, which is pretty interesting. Let's make sure that actually works. X equals ky squared. Oh, well, of course it will work. Never mind. Okay, so let's find the centroid of this area. Now, I know you can use the chart for this because we just showed how to do the chart for it. I don't remember what the answer was. You probably have it written down, but I just erased it. So how would we find this? We're going to do this by integration. Okay, you ready? How do you feel about integration? You love it?
Okay.
You feel okay about it? Okay, good. Okay, let's start with X bar. Okay, do you want to try vertical or horizontal boxes?
I guess vertical.
Okay, cool. Here's a vertical box. Okay, if this one doesn't work very well, we will try the horizontal boxes. Okay, so here's DA. Okay, so we want to know, so yeah, so we need two things for that box. We need X tilde or X bar or whatever, and we need DA. Okay, now remember that what's the coordinates of the top of this box are X comma Y. Okay, so what's where's the centroid of that box? If I were to draw it, where would I draw it?
Like around 10 millimeters.
Right. Okay, so here, let me just go ahead and draw this real quick. Okay, so it would be like halfway up. So in okay, so so you want me to draw it like right here, right? Oh, you froze. Oh, there you're back. Okay, so so if we draw it right there, what are the coordinates of that centroid? Okay, if the top of this box is X comma Y, what are the coordinates of the centroid of that square?
Of the bar.
Of the red dot.
So it'd be like somewhere around 15.
No. You're giving it to me as if there's red boxes in absolute. What if the red box were over here? Okay, and the coordinates here were X comma Y. Okay, or the box were right here. Okay, and we had a dot here and the coordinates were X comma Y. Okay, in terms of X and Y, okay, what is the X coordinate of this dot, of the red dot?
It would be the same equation as from the chart.
No, we're not using the chart.
Would it be X
Okay.
comma Y over 2?
Yes, it would be X comma Y over 2. Okay, can you see that no matter what? So if this is X comma Y right here, then this has the same X coordinate. And then, but the
Okay.
Y, it's halfway down. Does that make sense, Hannah?
Yeah.
Okay, so over here, the X tilde is going to be X. The Y tilde is going to be Y over 2. Okay. Now we just got to get the area of this thing. So this is a rectangle. So what's the width of that rectangle? Okay, so this is calculus. So whenever we ask for the width and it looks like this, that width is dx. Okay, what's the height of it? I want to know how far is it from here to here?
dy.
It's not dy. So dy would be if I drew a rectangle that was going in this direction. So this would be dy. But in this case, remember x comma y. So if something has x comma y, that means it's x going this way and it's y going this. Well, I went too far, but it's y going up. So it's y from here to here. And it's x from here to here. Okay, that's how the coordinate system works. So in this case, the height of this thing is just, so let's see, the width of it is dx. and the height of it is just y. Okay, that's the area of that rectangle. Okay, so this is using, I'm going to do this twice for you because we want to make sure that this makes sense. So this is a horizontal box. Okay, let's go ahead and do the vertical box. Oh, sorry, take that back. This is the vertical box, and this is the horizontal. So, sorry, this is vertical. Okay, we're going to do this again with a horizontal because this can be done either way. It's just going to be a question of which one is easier for us to solve. So we need an X bar, we need a Y bar, we need a DA. Okay, and so in this case, I'm going to redraw my whole thing. Let me erase this. Okay, and so I'm going to redraw my whole thing so it looks like this and like this. And we've got something that looks like that. Okay, and any point along here is X comma Y. Okay, and we know that this going down here, this is 30 millimeters. This is 20 millimeters. Okay, but this time I'm going to do a box going this way. Okay, so the coordinates here, this is X comma Y. So what we want to know now is the centroid of this thing. This one won't be as easy as the vertical. Okay, so let's start with the DA. Okay, what's the length and what's the width of this thing? Okay, the width is like right here. So what are we going to call that?
dy.
Would that be X, Y?
Well, this is a dy. Okay, because the width is always this little tiny incremental length is a dy. Okay, and then what we need is we need this length here, and that length there is a little bit tricky. Can you see what it might be? We want it to be X, but it's not X because X tells us this distance here. Any thoughts?
Would it be X over 2?
Okay, you've got the right idea. X over 2 would be about right here, though.
Could
Okay,
it
so in
be
this
x
case-
over 4? I don't know, but
Okay, so what we're doing is, so what we're going to say is we're going to say, okay, well, that distance is going to be this total distance right here, which is 30. And then what I'm going to do is I'm going to subtract off this bit right here.
so
Okay,
it's
so-
30 minus x.
So it's 30 minus X. So it's going to be 30 minus X. This is very hard. So especially this particular way of doing it. A horizontal box, I don't think is going to be the best box here. By the way, I like your cat. So all right, so let's try to find the I'm going to erase that. We may need it again, but I don't know. Okay, so let's find the X. Where's the centroid of that box? Okay, and so what we want to remember here is this distance is 30 minus X. This distance is 30. Is X. Come on, you can erase. Well, it won't let me erase. So let's just draw over it. That's an X. Okay. So how do we get the location of that X bar?
Is it 20 minus y?
Well,
Or no,
we
you're
have-
asking for x bar. Never mind.
Yeah. So the X bar.
Uh,
And this kind of goes back to what Hannah just said, is basically it's going to be X right here plus this thing divided by 2. Okay, because I don't want to go this full 30 minus x. I only want to go half of it.
Oh, I see. I see.
So we're going to go x plus 30 minus x over 2. And we'll probably simplify that if we would actually wanted to use this particular this horizontal boxes. But I think it should be pretty clear that these horizontal boxes are very difficult. Okay, so now we need the y tilde. Okay, what is the y coordinate of that dot? Okay, remember, this is y, this is x.
So that's 20 minus y.
Okay, 20 minus y would be, we go up 20. And then we subtract off y. So, yeah, so we go up, okay, yeah, so let's do it over here on the right here. So we go up 20. And then we're going to subtract off this bit. So 20 minus y would be this bit right here. Right, or more to the point for our current location, it would be we go up 20. And then we'd subtract off y, which is this bit. And that would leave this bit.
So it's just y.
It's y, exactly. Okay, so we're going to put a y right here. Okay, so now that we've done all this, which side looks easier, the vertical or the horizontal? Hopefully it's obvious that the vertical boxes are a little bit easier. Okay, so we were able to do that much easier. So we don't want to integrate with this. See, there's an integral here. We don't want to integrate this because mainly because of this. But also this is a little bit difficult. This actually isn't really all that difficult. But let's go ahead and see what happens. We might come back and do the horizontal. Let's just see what happens when we plug them in. So I'm going to use this formula down here. I'm going to say x bar equals the integral of, let's see here, x. So we're going to take this bit, x, multiply times a dA, y dx, like that. And then we're going to integrate in the bottom, we're going to have the integral of y dx, like that. Okay, so the problem here is that all of this is in x's right here. So I want all my variables to be x's. So the way we convert these y's, and we want to change these y's into x's so that everything matches. So I've got this formula right here, x equals ky squared. So I'm going to rearrange that. So that becomes what? Y equals the square, let's see, so x on k square root, like that. Okay, so I'm going to use that formula. So I'm going to erase these y's. And in place of those y's, I'm going to put, let's see, 1 over the square root of k. So I'm going to bring that out in front because it can do that. 1 over the square root of k. And this is going to be x to the 1/2. Can y'all see how I did that?
No, I'm really bad with like fraction exponents. Can you show me?
Okay, let me go ahead and do it. Okay, could y'all see how I got here?
Yeah, I get
Yeah.
that.
Okay, so then we've got y, so x to the 1/2 over k to the 1/2. So that's the square root of x over the square root of k. Y'all good? Or
Yeah.
okay. Go ahead, Hannah.
I was saying I understand.
Okay. So then I'm plugging those in for where we had a y. So we had a y right here. And so what I did is this 1 over k to the 1/2. Okay, I said k is just some number. We just don't know what the number is. We could figure out what it is, but I'm not too worried about it right now. And so what I did is I'm taking that k, that 1 over k, and I'm just bringing it out in front of the integral. Okay, and I'm leaving this x to the 1/2 inside the integral. Does that make sense?
Yeah.
Okay, I shouldn't skip steps. My apologies. Okay, the nice thing about it in this case is this 1 over k to the 1/2, it just goes away. Okay, because it cancels because it's on top and bottom of that of a fraction. So we get x bar equals. So to do this, this is x to the 2/2 times x to the 1/2. So that becomes, so we have to add. So that becomes x to the 3/2. So this becomes the integral of x to the 3/2 dx over the integral of x to the 1/2 dx. Okay. And since we're doing x's, that means we're going from x equals 0 over here till we get to x equals 30 on this end. Okay, so we're going to go from 0 to 30, from 0 to 30. Okay, so when we do these integrals, we're going to add, so the power rule, we're going to go to x to the 5/3, excuse me, the 5/2. So we add basically 1. And then we want to take the reciprocal of that, 2/5, like that. And on the bottom, we do the same power rule. We're going to go x to the 3/2. So we're going to add 1, so 2/2. And this will be 2/3, like that. And then both top and bottom, we're going to go from 30 to 0. And down here, we'll go 30 to 0. Luckily, those zeros don't matter. Are you guys following? I'm not hearing some
Yeah, I'm
pipe.
following.
Okay, so I'm just gonna plug those numbers in. I don't have to worry about the zeros, right? Because they're just gonna come out to be 0. So it's gonna be, let's see here, 30 to the 2.5 times 0.4 divided by, let's see, open parentheses, 30 to the 1/2 times 2/3. So let's see here, 2 divided by 3 times 30 to the 1.5 close parentheses equals 18. Oh, that's nice. The whole answer comes to 18. Nice and simple. Got to feel happy when it comes out pretty like that. Okay, and that's got units, so that's going to be 18 millimeters, which we didn't guess where this would be, but it seems a little reasonable. Like it seems like, okay, well, this is 30 in the x direction total, so 15 would be a good guess, right? If we were to go halfway, but then there's more area on this side of 15 than there is on this side of the 15. So to kind of shift it a little bit to the right would be a good guess. Okay, we're out of time, but I can do the y direction too if you like, or we can just call it. It's up to you guys.
What would be like the question for this problem?
It would be find x bar, y bar.
Okay.
Y bar is going to be a little bit, let me go ahead and set up y bar. It's going to be a little bit more difficult because k is not going to disappear. So I'll at least set it up. I'm also a little curious if it's going to be harder with the vertical box. I don't think it will be, but it's worth checking. Okay, so here we go. So y bar equals integral of the dA. So here's our dA down here. So integral of y dx. Okay, and then the top is going to be y tilde, so that's y on 2 times that dA, which is going to be y dx. Yeah, actually, I think this one's going to be a lot easier. Okay, so I'm going to bring that 1/2 out front. 1/2 integral. Okay, y squared dx over integral of y dx. Again, I don't want y's, I need x's. So I'm going to do here is I'm going to go in here and use this right here, or more to the point, I'll probably use like this, right? So I'm basically going to say y equals x to the 1/2 over k to the 1/2. Okay, so this actually is going to be nice on the top because we're going to square that, which is going to become really nice and easy. So y bar equals 1/2 of the integral of y squared. So it's going to be x to the 1/2 over k to the 1/2 squared dx. And on the bottom, it's going to be the integral of x to the 1/2 over k to the 1/2 dx. Okay, we're running out of space. I'm going to end up having to like loop back. So I'm going to erase this. Hopefully we won't have to, you know, hopefully I want to know. By the way, the expectation here is to get a value. So we would expect, so half of 20 would be about right here. So that would be 10. And so we're going to expect it to be a little bit higher. So maybe 12 or 12.5 would be my guess, but I'm not 100% sure. The big problem here is we don't know what K is. We can solve for that though. So we'll get that in a second. So let's see here. So when we square, we multiply. So 1/2 times 2 becomes 1. So we end up with y equals 1/2 of the integral of x over k dx. That one's easy to solve. And over the integral of x to the 1/2 over k to the 1/2, which is more annoying. Okay, dx. Okay, so in this case, what I'm going to do is I'm just going to bring the k out, and I'm bring the 1 over k to the 1/2 out, because those are annoying and I don't want to deal with them. So I've got x on top and x to the 1/2 on the bottom. Okay, so xd, and again, we're going from 0 to 30. Okay, so I've got, so I'm going to combine these right here. So I've got 2k on the bottom and k to the 1/2 on top. So I end up with 1 over 2k to the 1/2, which is a totally annoying number. Okay, and I'll if you want afterwards, we can go over how I got that, the exponents. And then we're left with, so this becomes x squared to the 1/2 using that power rule, going from 30 to 0. And on the bottom, it becomes x to the 3/2. And this is 2/3. Okay, and again, that's going to go from 30 to 0. And I'm going to kind of put this in brackets just to separate it off a little bit. Okay, so this is going to be 1 over 2k to the 1/2 power. I don't know why I can't draw little 2's with this. And I'll just plug these in. So this top becomes 450. Okay, because that's 900 divided by 2. And this bottom I can't do in my head. So let's do 330 to the 1.5 times 2 divided by 3 equals 109.54. So what's that? So it's going to be 225 divided by 109.54 equals, whoop, clear, hold on. 225 divided by 109.54 equals 2.0540 divided by k to the 1/2. Okay, so this is annoying because we kind of end up in like a weird, well, we didn't quite solve it. And that's true because we need to get this k. And the way we get this k is, what we do is we go up here to this original thing. I would ask you to solve this with k, just leaving k as it is. But in this case, we've got a number right here, which is 2030. Okay, which is 20 comma 30. And I know my equation. So my equation is from right here. It's x 20 equals k times y squared. So times 30 squared. So that's from x equals k y squared. So k then equals, let's see here, what is that? 20 divided by 900. Okay, so 0.02222, basically 2 is repeating. Okay, so if I wanted to, I could plug that in right here. So I can take the square root of that to the 0.5. Okay, and then, so if I plug that all the way in, I get that y bar equals 13.779. Okay, millimeters, I think, yeah. So this is why, by the way, this is why we use the chart, right? Because we don't want to, because it's a lot easier this way. So it becomes x bar equals, what's that?
I was saying, so it can be solved either way, though, with the chart or with the integration.
Ideally, but you have to know how to integrate. So I will give you, so there will be one where I say solve by integration. Okay, and well, on the final, there'll be one where I say solve by integration. There'll be one where I say solve by, the chart. Well, I won't necessarily tell you to solve by the chart, but it will be, because if it's a bunch of squares and rectangles and triangles, then you immediately look at it and go, okay, this one, I need to use the chart, right? I'm not going to integrate. Like the last two we did, you wouldn't integrate those because that would just be ridiculous. Like it's just too hard. But if you can integrate it, I'm going to tell you to integrate it. So this is confusing, I know. And the problem is, of course, we teach you calculus and then we don't ask you to use it. And then all of a sudden it shows up and it's like, oh my God, this is really abstract and hard to think in terms of X and Y's. I want to think in terms of 20 millimeters and 30 millimeters. So it's a bit of it's a brain twister. And, obviously I will help you as much as I can, but you just need to practice these. Okay. And I'll just have to create like a worksheet of practice problems for this. Cause going through that, my practice set for the what do you call it? I didn't give you any of these. I didn't give you any of these. So I need to create a practice with, I'm writing a note to myself right now. Create practice with integrating, what do we call these things? Centroids. Okay, so I'll try to post that in a few minutes actually. So hopefully that will help, but you're gonna have to practice this. Once you practice it, it still becomes a pain. And like, for all I know, I might've made an error in here because it's not easy. And there's a lot of things that go on, but once you practice it a little bit, it becomes kind of second nature. So for the Centroid homework, I guess we'll just do what, Friday. I did post a video of a lady who does exactly what I just did right here. And she does a really nice job with it. Okay, so I recommend watching that one. It's also the same problem that I assigned. So, it's like 3 points. We don't care about the points. The point is to learn it. But if you watch her, she explains it very, very, very well. Okay. Okay.
All right.
So that's the end of this, and have a nice weekend.
All right. Thank you. You too.
All right. Thanks, Hannah. Oh, so the first half of this was just kind of like me and you talking. Are you okay with me posting that onto YouTube? Or, I mean, if you don't want me to, I don't have to.
No, that's fine.
Okay. Well, then I will post it. All right. Thanks, Hannah.
All right. Thank you.
All right. Well, let me know if you need me.
All right.
And also, I'm sorry I didn't get your email until too late the other day. That was, sorry about that.
Oh, it's fine.
Okay. Well, I mean, it just kind of stunk because it was right before the test, right? So, so